The opinions expressed by the host and guests in this show are not necessarily the views of Children's Health Defense.
Good morning, CHD. It is Friday, the 28th of August, 2026. We're live here at CHD TV. Okay, this is our show today. In just a moment, we're going to be bringing on our Chief Scientific Officer, Brian Hooker, to continue our talk about measles, the latest on the measles media madness. Then we're going to go to Bob Schwartz and Edward Jones, and we're going to be talking about the Lindsay Clancy trial, followed by Doctors and Scientists, Power of Sunlight with Jonathan Jarecki. And Jonathan, we're debuting him today, but Jonathan will be a regular host for the science department on CHD TV. So we're very excited about it. He's very young and he's super clever. So we'll be talking more about that later. But now let's bring on Brian Hooker. Good morning, Brian.
Good morning, Paulie. How are you? Good to see you. The latest update on the measles is we can't find the second case. There really is no second case to be found. The coroners and the officials from the 6 counties around Lancaster County have none of them have been able to find the second quote unquote measles death. And we know that based on what you reported yesterday, I believe it was either yesterday or the day before with Carl Jablanowski, that this individual, this little baby who died on the first day of life, evidently tested positive for measles antibodies and did not die from the measles. We know from the coroner's report that this baby died from a ruptured spleen due to birth trauma in a home delivery setting with an unlicensed midwife. Okay, so the midwife that was attending this particular birth did not have a birthing license. And so it was, something that was, done during labor and delivery, and a spleen rupture. That is something that is, associated with the birth trauma. There weren't any treating practitioners there during the time, and so the baby ended up bleeding to death and passed away. But it has absolutely nothing to do with the measles.
Again, same playbook. We're doing the same thing again as we did with the Mennonites. Um, Brian, one of the things that's concerning me, and Carl and I did talk about this, is this antibody measles test. I mean, they could do that on anyone who's had the MMR. I mean, Billy was sky high with measles antibodies
Right.
after the MMR. So do you see where this could go? It could be really dangerous.
Well, it's very, very foolish of them to come out and claim this. And not only was it Governor Shapiro that claimed this, but it was also the Secretary of Health, who was a Governor Shapiro appointee, that somehow if you've had measles antibody, that means that you have an active case of the measles. They did not say what type of antibody it was. There are various types of antibodies. If it was just IgG, that's the circulating antibody that you get if you're exposed to the measles or the MMR vaccine. If it was IgM, that may indicate an active measles infection. But again, it's a moot point. You would not vaccinate a newborn baby. I mean, this was baby literally coming out of the birth canal, that during the autopsy, this was after the baby passed away, that is when they confirmed that there were measles antibody, not even the genetic material. Measles is an RNA virus, not even the ribonucleic acid associated with the measles was in this baby's system, just the antibody. And so it's very, very chilling. It was a setup in order to besmirch Secretary Kennedy. It looks like it was a ploy for the midterm elections. Evidently, Governor Shapiro is up for re-election in 60 days. He's obviously one of the individuals who's a candidate for, or a supposed candidate for the next presidential election cycle. And it's very, very unfortunate that this fear porn came about. But it also reflects directly on the level of tension and the level of fear inside the Amish and Mennonite communities of Lancaster County. They don't really deserve this. They don't really need this. They've been in the news already because of the New York decision that really tramples religious freedoms in the United States for everyone. And so that, right, again, the Amish and the Mennonites are in the crosshairs. There were even reports from an Amish community leader that they were telling the Amish that, oh, well, we could vaccinate you in private so nobody would know. We could go into your basements and we could just let you, get vaccinated, and then nobody knows that you're vaccinated, but your children are protected, not realizing that this violates the religious conscience of the Amish religion. And, so they would get no takers on doing that, but they were very, very desperate to, check that box, say that the Amish community was vaccinated, and that they would not have kept that secret. That was probably a bold-faced lie that was told directly to the Amish so they could check that box, and then they could go to mainstream media and say, look, now we've vaccinated Amish people.
And Brian, meanwhile, there's a parent somewhere with a poor newborn baby who they've lost, and their baby is being used as political gain everywhere. I mean, it's you've got to feel for the parents. That whole case has just been highlighted around the world. And one other thing, just while I'm at it, so they've messed up. They've messed up with the measles. We found them out. They lied. There are no measles deaths. Okay,
Right.
this is one big lie. So what are they going to do? Oh, I know. Let's bring out Samoa, the situation in Samoa, all over the press, and how Bobby killed so many people, which is completely untrue. There's a massive backstory behind that, which has nothing to do with what the media are portraying.
No, it has absolutely nothing to do. This is something that Josh Green trotted out around the confirmation hearings, and pharma acolyte Bill Cassidy, how somehow Secretary Kennedy went to Samoa in order to manipulate vaccination rates to recruit more anti-vaxxers. It had nothing to do with measles. It had nothing to do with vaccination. But they use this as fear porn of all these cases of the measles where individuals died. No, they had a bad batch of measles vaccine. They had an absolute bad batch of measles vaccine. And if there was vaccine hesitancy among the Samoan population, is because that they saw so many people die because of medical error around this particular batch of the vaccine. So it's unfortunate. They lie again. There will be no culpability. These people seem to be like Teflon. They can lie in front of the media. The media will go with the lie as long as the lie supports the media's narrative, which is controlled by the pharmaceutical industry. And again, I'm thankful for CHD TV. I'm thankful for the other outlets that dare tell the truth about this, because it is not what you're hearing on the mainstream media.
No, and the trolls have gone awfully quiet at the moment.
Yes.
So, Brian, some good news here. Paper Reinstated. Tell us about that.
Right. The paper that I published with Neil Miller in 2020, Analysis of Health Outcomes of Vaccinated and Unvaccinated Children, Developmental Delays, Asthma, Ear Infections, and Gastrointestinal Disorders. It was on May 18th, was put up for an expression of concern due to an anonymous complaint. We have addressed that complaint, showed that it was fake news, that it was false, that somehow the source of the data that we named in the paper was incorrect, and that we somehow violated in some type of ethical tenet by doing this. The journal did require that there would be what's called a corrigendum, which says that the individuals who were responsible for allowing us to use their data we were put in contact with them by FOI. Now, this is really splitting hairs. We have to acknowledge the Pediatric Health Outcomes Initiative because they introduced us to the pediatricians who ended up collaborating on this particular paper. We did not name the pediatricians because we want to protect them and we want to protect the patients in these pediatric practices. But the journal would not reinstate the paper without that one provision that we acknowledged the Pediatric Health Outcomes Initiative. Neil Miller and I agreed to do that, and now it's reinstated. No expression of concern. This paper stands, and it's important because this is the last standing true vax-unvaxxed, completely vax-unvaxxed paper showing differences in health outcomes on PubMed. Okay, so they've taken down the paper by Anthony Mawson, they've taken down the paper by James Lyons Weiler and Paul Thomas, and this would be the last one that was there. So we fought really, really hard to keep the paper up and online, and I'm sure it will undergo additional persecution, but for now it still stands.
That's amazing, Brian. Well done. Congratulations. And all the hard work and perseverance. And thank you to your science department, the Children's Health Defence, for covering the measles so brilliantly this week. And we will continue to do that until this is over. But I have a feeling they're going to have to cover it up with some other big news now because they've made such a mess up.
Absolutely. Yeah. More to come. More, nothing to see here. For Governor Shapiro's big measles debacle. He stepped in it, and he stepped in it royal.
Brian, thank you for being on this morning. We so appreciate you.
Thank you.
Okay, everybody, let's go straight to Bob Schwartz and Edward Jones. Good morning, both of you.
Good morning.
Good morning, Polly.
Well, now this whole Lindsay Clancy thing has been, it's been very confusing because the social media are taking it in all kinds of different directions. So it's best to get you guys on and get us up to date. What's really going on here?
Polly, this is definitely a historic case that's going on in regards to the Clancy trial. I don't think anybody in the country has seen a case like this where it's basically you're getting one side that says justice must be done for the 3 children that were murdered, and then we have a very compassionate side that's going on in regards to the medication treatment that was prescribed to Lindsay Clancy and her postpartum psychosis that she was suffering from. And it's really interesting, the word semantics that they're doing in this case. That it's a postpartum psychosis, and they're really avoiding the terms of medication-induced psychosis from all the medications that she was on. It's again, it's very, very interesting to see how this is going to play out, and whether it's going to be a not guilty or a guilty verdict.
Yeah, I'm going to bring you in, Edward. But I just want to say, to make it absolutely clear to everybody, I mean, this is a tragic case of 3 beautiful children that lost their lives in the most unimaginable way. But we're trying to get to the bottom of what actually happened here. So, Edward, I wonder if you could bring us up to there. Look at that picture, those poor children.
Exactly. Yeah, as Bob said, I mean, it's clearly a medication-induced psychosis, and it was interesting in the closing of the prosecutor yesterday. She circled back to this notion that just a few pills of, say, Zoloft could cause any kind of bad problems, and she also circled back to it's perfectly okay to be taking 2 to 3 different drugs at the same time. And as Bob and I know, that is such sophistry. There are cases all around the world where just a pill of Zoloft or several pills have caused eerily similar tragedies to this one, just that. And then there's Prozac. And I'm glad we've got this chart up. This was compiled by Linda Martin, who is affiliated with the Southern Network on Adverse Reactions, and she's got a PhD. And if you look at this, first of all, these are from the FDA's own data. So if you look at, say, the Zoloft, you go down the line, and we have to keep in mind that only 10% of adverse events are ever reported. So it's almost like you should at least add a 0 to all of these figures. But you've got Zoloft, homicides 167, homicidal ideations 251. I think one of the more fascinating ones, you go down to hallucinations, including auditory, visual, and mixed, 2,666. Add a 0 to that, and there's all this testimony that these drugs cannot cause hallucinations, command voices, things like that. That is utter sophistry. And then you go down to the bottom, and psychotic disorders, 795 for Zoloft, over to Prozac, 683. You go back up in the Prozac column, hallucination, including auditory, visual, mixed, 1,697. So, there's so much sophistry being placed around. But and as Bob was mentioning, Kevin Reddington did say yesterday in his closing that it was, quote, correct me if I'm wrong, Bob, it was the damn medicine, and she was failed by the psychiatric and medical community.
It was the damn medicine and lousy medical care, which he opened up with that yesterday, and I thought, oh my gosh, this is going to be a great opportunity to really education about medication. But he kind of went in a different path, as far as really diving into the case, and he didn't really talk about adverse events. He didn't talk about informed consent, or he didn't really talk about the black box warnings that come with these drugs. And it almost feels like it was a missed opportunity. And nobody knows this better than I do as far as what happened to me back in 2004. I went to see my doctor for back pain, and at that moment he should have referred me to a therapist, or maybe a therapist, because I was having cognitive issues because of the pain. And instead, he gave me a prescription for a drug called Concerta, for ADHD drug. I took it for 5 days, and I suffered a psychosis. And if you could, maybe you could play that of what I went through. After 5 days of taking the medication, on the 6th day, I was sitting in my executive office, and I was overwhelmed with the feelings that somebody was after me. Somebody was going to hurt me, and that I had to get out of that building right away. Got in the elevator, got to the bottom floor, and I ran to the front of the building. Then I kind of paused and turned around. I think I was actually, at that moment, witnessing my own mind. Why did I just do that? That's when I knew something was terribly wrong. I was overwhelmed with paranoia, and I had suffered what I found out later to be an acute psychosis.
Shocking.
And that was just the loss of reality of what was going on. And I was a 40-year-old father of 2. and I'd never experienced anything like that before, as far as slipping in and out of consciousness, and that was the beginning and the start of my long tragedy, a journey. And by the grace of God, I didn't harm anybody, and I didn't harm myself. And for over 22 years now, I've been trying to alert officials, go to every source there is to that could help me and my family at that moment. And it was just met with silence. It was met with gaslighting me and ghosting me in regards to help. And I think that's exactly what happened to Lindsay Clancy when she was going through all her problems. The sad thing about this, Polly, is that she had postpartum depression, which is a temporary problem. In talk therapy, it would have been solved probably in 6 months, at the longest a year. But they diagnosed her with an adjustment disorder, and then they started medicating her, and it was a slippery, sliding path to 3 children that are no longer with us today.
Right. And I just want to say, so let's talk about the media, because they are clearly not helping. And so the images we just saw of those women there, the media are portraying them as these women are coming out to say, let's kill our kids. That's not what's happening at all. They're talking about how they can't get help and they're overprescribed on these drugs. Let me get this clear. These women are not out there to say, it's great that Lindsay did what she did. They're out there to say, this is not okay, that we do not get the help we need and we're just given psychotropic drugs.
Exactly. They're lifting up Lindsay for helping to and her team, helping to create more awareness about the problems surrounding healthcare with women who are suffering from postpartum depression. Yeah, it's not like they are validating what she did. They just and they're showing their support for her because they believe that she was in the midst of a psychosis when she did this horrific act.
And I have to say to you both, it's very hard as someone that has never been on psychotropic drugs or medication of any kind to understand what you're telling us. We're hearing you, just like people when they see the vaccine injury stories. If you haven't lived it, it's hard to believe. And so
Exactly.
a lot of people are being very judgmental about this because it was so awful what happened to those children, like barbaric what happened to those children. But what we have to try and understand is exactly what you're talking about what these drugs can do to change you into a completely different person.
Exactly. Yeah, it's almost like only if someone in your family has suffered an event like this or something related to it, or has had a suicide event and has been on these drugs, are you really made aware? Because as we know, for years the pharmaceutical companies have been putting out this essentially propaganda that depression is caused by a chemical imbalance in the brain. And we now know that is a complete myth. There's zero scientific evidence that depression is caused by a chemical imbalance in the brain. And there's been studies that 80% of Americans and 80% of the people in the UK believe that myth. So, it's so hard to punch through all of that. And, I write about a case in my book involving a BBC trained documentarian named Katinka Blackford Newman. And she was going through a painful divorce. She took one Zoloft pill, experienced akathisia, stabbed herself several times in the stomach, and then, was taken into a hospital. She thought she had killed her children. She had this complete psychosis caused by one pill, and she thought she had killed her children. She went on to write a book called "The Pill That Steals Lives," and it's about cases around the world similar to hers. And she writes in there that, if you had come to me and said that Zoloft or Prozac or Remeron or something like that could cause a psychotic break, I would have thought you were a conspiracy theorist. So I think that's what we're dealing with.
Yeah, and they had these medications out like candy. I mean, Bob, you went in for a backache and got an ADHD medication. What is going on? I mean, they're just doling them out to people with no care for what all the outcome will be, which is, I think, where we need to be concentrating on. What can we do to stop the mindless giving of these drugs?
We have to put a tourniquet in regards to handing out these medications to young children. I mean, we got to protect the children's blood-brain barrier, from medications like this, because these drugs alter children's brains, and not enough people understand that. You know what? They could be suffering from thought disorder, faulty thinking, cognitive impairment, impulsiveness, all under an umbrella of apathy. And this is just, again, a very dangerous situation. And we are at a critical, epidemic, which Dr. Amen just did a clip the other day to really talk about the dark period of time that we're going through. If you would like to play it.
What topic is no one talking about now that historians will study in the future?
Well, from my perspective, it's the insanity of the mental health industry that is destroying the mental health of America, making diagnoses based on symptom clusters with no biological data, then drugging people. Last year, there were 337 million prescriptions for antidepressants. 27% of all doctor visits, no matter the specialty, 27% someone's leaving with a prescription for a benzodiazepine like Xanax or Valium. This is an insane time. And they call me crazy, and I'm not crazy. They're going to be talking about this dark period in psychiatry for centuries to come.
Jesus.
Well, Bob and Ed, if you can keep us updated on this and educate us, thank you for your education, not just on the Lindsay Clancy trial, but keep those stories coming so that we learn through you both of the dangers of these medications. Can't thank you both enough. And
we're going to get this fixed, Polly. We have to.
Yes, we do. And we'll put the link to Bob's film in the show notes, but also to Ed's book as well. So keep educating yourself, people. And we're so grateful to you both. Thank you so much for being on this.
Thank you, Polly.
Thank you very much.
All right, everyone, we're going to go now to Doctors and Scientists, and please pay attention to Jonathan. He is our new find. We're very excited. He will be on doing his first segment for you on Monday. But for now, Brian Hooker is interviewing him. So pray big, stand firm, never settle, and I'll see you soon.
Well, good morning, everybody, and welcome to Doctors and Scientists. I'm your host, Dr. Brian Hooker. This Friday morning, we have such a treat in store for you. Not only does our guest have a wildly popular podcast on my favorite topic, science, and mostly physiological science, but he's also joining the CHD team coming on August 31st. You've never seen this level of enthusiasm in an individual. You just sort of kind of wind him up and let him go. Jonathan Jarecki, welcome to the show. Thank you so much for joining us today.
Thanks for having me, Brian. I'm excited for this.
Well, we're excited to have you. I have to say, welcome to the CHD TV team. We're pretty family oriented. We're very, very excited to have you. And tell us a little bit more about your background.
Yeah. So I'm a 21-year-old. I'm in college right now, going into my junior year of college at Davidson College in North Carolina. And I'm studying biology and minoring in neuroscience up there. And I was raised in the holistic space. My parents were very health conscious, and we focused a lot on prevention. And I always tell people my infrared sauna is older than myself. It's like 35 years old. My family is infrared sauna. So we've been on this, since like day one. And my mom really, instilled in us, I have 3 older siblings, so her 4 children. She really instilled this idea that the body has the innate capacity to heal. And that if we put it in the right condition to do so, then it actually can, right? And that we don't need to necessarily, rely on, doctors for our health, and we can put our health in our own hands. Again, looking at this from a more preventative standpoint, and so that's really how I was raised. So in this understanding that lifestyle has a huge impact on our health. So diet, exercise, nature, sunlight, which we'll talk about today, and all these other just different modalities and different pillars of health. And around like 3-4 years ago is when I started really diving deep into the science behind all the practices that I did growing up. Because before it was like it was like my mom's opinions and everything that I held onto and so strong. So I had these really strong opinions, and they worked out for me. So I'm super fortunate and blessed to have my mom raise me in that way. But I had these really strong opinions and on a lot of different beliefs, and I wanted to have a backing on like, all right, why did I believe these things? So started diving deep started listening to podcasts, started reading books, and then I really started diving deep into the primary literature. And that's what has really been the most like fruitful thing for me, is like really seeing what the research actually shows. And that has been my passion for the past few years, and then communicating that on social media, primarily on Instagram, and just sharing the science with people. And yeah, my focus recently has really been on light. Growing up, we never had a fear towards the sun or anything like that. My mom always had us going outdoors and playing sports and all these things outside as much as possible. She never really put sunscreen up growing up on us, and we born and raised in South Florida, so Sunshine State over here. And so I had that sort of background. And then, when I was diving deep into all this literature around, different health modalities, I found this idea that that sunlight has a huge impact on the human body. And I dove super deep into this rabbit hole of circadian biology and photobiology and all these things. And for me, I started implementing more and more of these light practices and focusing on my light environment, as I like to call it. And it really, I see it as like there's no going back once you dive deep into this rabbit hole, especially the research.
Absolutely.
So that's sort of a little bit about like the background of how I got here. And yeah, I've just been loving sharing this information to the public.
Well, I love, anything about sunlight. I've got sort of this newfound fondness of sunlight, and try to get out in the sun in the day, for at least 10 minutes, 15 minutes, something to say, yeah, I've been able to be in full spectrum sunlight. It was a struggle for me because growing up, I was allergic to everything that grew. I mean, if it grew outdoors and it had pollen, then I had an allergy to it. So it's sort of, my allergies have calmed down. That's one of the nice things about old age. But tell us more. I think if we, obviously, if we talked about the benefits of sunlight with the body, we would be here until, 5 o'clock at night.
Yeah.
And you developed such an expertise around this. How would you like to winnow down today on, which facet of sunlight are you really fascinated with?
Yeah, so I think the first thing to understand is like the full sunlight spectrum. I know I have a chart up there where you see the full sunlight spectrum and what that includes, and that goes all the way from the UV light, so an invisible wavelength of light, to the visible, which is red, orange, yellow, green, blue, purple, violet. That is what you see on a rainbow, and then infrared. And the vast majority of the sunlight spectrum is actually in the infrared wavelength. So infrared is just beyond red light. It's an invisible wavelength to the human eye, so humans cannot see this wavelength of light, but other animals actually can see infrared, but we humans cannot see it. And it actually has such a profound impact on our biology, and more research is coming out about this. And so the vast majority of sunlight is infrared. And one really important thing about infrared is that infrared, when it gets in contact with our body, it actually doesn't really absorb too many things within the body. So there's a beautiful paper published out in University College London by Glen, Jeffery, and his colleagues, where they have shown the penetration effects of infrared. And we've actually discovered that infrared light can penetrate completely through the human body. And so this we see this because when an infrared photon basically interacts with the body, it will come into the body, scatter a ton. So it's going to bounce off a bunch of things until it finds something to absorb. One of the primary things it absorbs is the mitochondria, and we'll talk more about like why that is super important. But this is just gets to this idea that the infrared portion of the spectrum, right? Although we can't see it, it is playing an effect on the human body. And we'll talk about a little later, like, how the indoor environment is actually completely void of infrared light because with, we looking at this from a more primordial standpoint, right? Humans have been adapted to full spectrum sunlight 24/7. So our body expects full spectrum sunlight all day long, 24/7. Even at night, we have tons of near infrared in the environment because moonlight actually reflects a lot of near infrared. So that's another, interesting nuance point there. Even when we would have been sleeping in our primordial state, we would have been bathed in infrared light. But outside of that, we would have had full spectrum sunlight 24/7. And as we have modernized, our society and we moved indoors, the first like artificial light was actually like firelight. So we can think of like firelight as like the first artificial light, but firelight is a much more similar to sunlight than let's say like a standard LED light bulb. So firelight has tons of infrared light. Now, when we moved into the indoors, we started creating LED light bulbs and fluorescent light bulbs, and we tried to become more energy efficient. And what that basically meant is we got rid of those quote unquote, wasteful wavelengths of light, that being infrared. The lighting industry thinks that infrared wavelengths are wasteful because, we don't see infrared. So it makes sense that, we want to brighten up the indoor environment as bright as we can while using the least amount of energy. So let's remove all the parts of light that don't play a role in us seeing stuff.
I was reviewing the slides before the show, and this really tells quite a story.
Yes. Yeah. So this basically shows us, that transition of where we are today, right? So this slide is by a doctor who I have worked with and working with right now on some projects. His name is Dr. Alexander Wunsch. He's an MD, PhD out of Germany, one of the leading integrative photobiology experts in the world. And yeah, what he shows here is that we look at that left chart, and that is the full sunlight spectrum, right? So we have tons of visible and then tons of near infrared as well. And what's interesting, so those little troughs where the near infrared is, that is actually water absorption in the atmosphere. So water absorbs a ton of infrared. So when we look at full sunlight spectrum, we see these little drops, and that's just an interesting, fact there that it's actually the water in the atmosphere that's absorbing specific wavelengths, and that can actually get into important stuff with with our physiology and stuff. But anyways, and then when we look at incandescent, you see still tons and tons of near infrared, and a lot of red light there as well, and little amounts of blue. Now, when we look at that LED light bulb, this is what we see. We see a huge spike in the blue, and then some green, some red, but zero infrared light. And this is the lighting that we are indoors all the time, right? And I think the stats like 93% of Americans' day is spent indoors, and void of any of this natural, near infrared light wavelengths or infrared in general. No infrared in the indoor environment.
And LED is comparable to fluorescent as well. I mean, if you have because they're LEDs primarily compact fluorescent lights. Is that correct? I was trying to make the connection because I'm sitting under fluorescent lights right now.
Yeah, they're very similar. So if you look at like a fluorescent spectrum, you'll just see a bunch of different spikes throughout the visible range. Again, basically zero infrared as well. I'm sitting in front right now of an incandescent light bulb, getting that near infrared shining on me. I think that's like one super practical thing that people can take away from this is like getting that near infrared back in the environment. And I'll talk about a little bit why is this near infrared so important, right? So we know, like I mentioned, the near infrared light can penetrate completely through the body. There's a great figure by Bob Fosbury, who's an astrophysicist. The hand, you can see a human's hand where we have an infrared a light source at the back of the hand and a camera that can actually see infrared. And all that white you're seeing there with the hand is infrared. So we see this infrared is penetrating completely through the hand. So that's a great visual picture that people can see there. But then we have a peer-reviewed published paper published in Nature Scientific Reports, a very prestigious journal, last year, where Glen, Jeffery, and Bob Fosbury have discovered that this infrared light can penetrate completely through the human thorax. So they actually they took participants, they brought them outdoors into full spectrum sunlight, and then on their backs, they had a little a device that could measure the light coming through their backs. And what they saw was that there was infrared light penetrating and coming through the back of these individuals. Now, what's interesting is that very little amount of the infrared light made its way all the way through the back. The majority of it, now some of it could potentially have been bounced back off from their chest, just back into the environment, but the majority of it was absorbed in the body. And getting back to that point that I was making, where is it being absorbed? Well, the primary place that that infrared light is being absorbed in the body is the mitochondria. So mitochondria are these little organelles inside of every single one of our cells, besides red blood cells. Our red blood cells don't have mitochondria, but besides red blood cells, every single one of our trillions of cells have many mitochondria. Within one cell, there can be, up to like 1,000 mitochondria, depending the cell. Different cell types have different amounts of mitochondria. And these little mitochondria are they're conventionally thought of as the powerhouse of the cell, right? But there's so much more. There's so much more to that. And yeah, this little diagram here, I think, is super important. I drew this, and basically what we're seeing here is the electron transport chain of the mitochondria. So in the mitochondria, there's two membranes, and the inner mitochondrial membrane is where the electron transport chain is. This chain of protein complex is where electrons, or energy essentially, gets funneled through. So we have this energetic flow of these particles of electrons funneling through our mitochondria all the time. And this then produces ATP, adenosine triphosphate, which is thought of as the energy currency of the cell. It is what allows our body to function. Without ATP, no cells are able to function, and we basically die. So we have been, with more and more research coming out now, there's two sort of primary mechanisms of how infrared light affects the mitochondria. And those two mechanisms are infrared light, red and infrared light, can be absorbed by that fourth protein complex on the electron transport chain, cytochrome C oxidase. It gets absorbed by that protein complex, and then what happens is protons get pumped up against the other side of the membrane, basically creating this charge gradient. So basically charging your mitochondria like batteries. That's what your mitochondria basically are. They're these little batteries that get charged up. You create this voltage within the mitochondria. Nick Lane, who is a researcher in London, he has done some amazing research around mitochondria and evolutionary biology. He has a book all about mitochondria called Power, Sex, and Suicide. And in that book, he describes this idea that for the size that mitochondria are, because they're super small, right? We can't see them with the human eye. We need a microscope for that. But for the size that mitochondria are, and that voltage potential within the mitochondria, we basically have a lightning bolt of energy within every single one of our mitochondria, all throughout. And this is constantly happening. And when we get that red and infrared light absorbed by the mitochondria, we're increasing that charge, increasing that voltage, allowing for more ATP, more cellular energy to be transformed and produced. And then another sort of mechanism at play here is that our mitochondria have tons of water, just like all of our cells has a cytoplasm, and our cells are basically, these little gel-like cells that have tons of water in them. And around that fourth protein complex, I think this is super cool. I mean, mitochondria are super fascinating, but the last protein complex on the electron transport chain is ATP synthase, which is this basically small little nano motor, and it's quite literally a motor. At the end of it, it's a rotor that spins super fast, and with each spin, we can pump protons back down, producing ATP. Now, around the ATP synthase, there's a lot of water, and that water can be very viscous. Infrared light can absorb the water, reduce the viscosity, allowing the rotor to spin faster, more ATP being produced. And we see this in cell culture studies. We shine red and infrared light on cells. We can test the levels of ATP in the mitochondria, and we see ATP is being produced. And we see this in vitro, in vivo studies as well. So we clearly know that red and infrared light is able to affect the mitochondria on that level. And so the real question here is now, like, all right, well, what is this? Like, why is this important, right? Why is this infrared light affecting the mitochondria? Why does that have any significance to health? Well, at the foundation of pretty much every chronic disease is pretty much mitochondrial dysfunction. And so I think one of the really important factors of health is having healthy mitochondria. I mean, mitochondria are the foundations of how our cells and how our organs and our body, the whole system runs and functions. And so if mitochondria are running at a lesser capacity, essentially, right, they're not going to be able to transform more energy, and they're going to have we're going to have consequences within the cell, consequences within the organ, consequences within the whole system of the body. And I think one of the big things is like metabolism.
Right.
So Glen, Jeffery out of the University College London is really one of the premier like researchers on how longer wavelengths of red and infrared light affect our mitochondria. And he has shown beautifully in some amazing studies how long wavelength light affects our metabolism. And again, our mitochondria are these metabolic sites within the cell. And so what's interesting is there's a few studies I like to mention. There's this one study on bees. So Glen, Jeffery and Michael Pounder did this beautiful study. They started it on bees because they had all of this research being formulated where they saw that, all right, we shine the red and infrared light on mitochondria, we increase ATP. So their thought was, all right, well, if this is happening, if we shine red and infrared light on humans, we should see blood glucose levels decrease, because if mitochondria are basically speeding up their metabolism, well, then they need more glucose. If they need more glucose, the blood glucose is going to decrease because they need to take that glucose from the blood, reducing blood glucose. That was sort of their hypothesis here. And they're like, all right, before we make fools out of ourselves, let's do this on bees first, and then we can see if we can do this on humans. And so what they did is that they had 3 groups of bees. They had a control group, they had a red light group, 670 nanometers of red light, and then they had a blue light group. And what they saw is that when they shined the red light on the bees, they had around 50% reduction in blood glucose of these bees. And now it's not blood, it's hemolymph. Bees don't have hemoglobin, they have hemolymph, but essentially the exact same thing. Around 50% reduction in blood glucose. And I have a figure up this if we want to put this up.
Right.
And there was also, when they shined the blue light on the bees, there was around 50% increase in blood glucose. So that was another really interesting aspect.
Is that surprise? Do you know the mechanism behind using the blue light? Because that's really predominant in LED and fluorescent lights.
Exactly. Yeah. And so that's the problem, right? And so we do know the mechanism out here. So within some of these protein complexes on the electron transport chain, we have these porphyrin rings. And these rings are very absorbent of blue light. So they absorb blue light and they create reactive oxygen species when they absorb blue light. So now we're creating these reactive oxygen species within the mitochondria that can damage the DNA of the mitochondria, can damage the DNA of the cell. Reactive oxygen species in and of themselves are not this terrible thing. They act like our body requires them for cellular communication, but too much reactive oxygen species is when we have this, oxidative environment within the cell. So that's what they discovered with this bee study. So they're like, all right, it's time to move this on to humans. Let's see what happens when we do it on humans. Now, what's interesting, and Glen Jeffery talks about this, and he saw it as unethical to shine the blue light on humans, which is why when he did the study, he'll only shine the red light on the humans. When we think about this, well, we're the guinea pigs, we're the experiment. Our modern indoor environment is the experiment. We're getting tons of isolated blue light, very little red, very little infrared. But I think that's just like a funny note that he saw it as unethical to shine the blue light. But when he shined the red light on humans, so what he did is it was a randomized placebo-controlled trial. So there was a control group, placebo. Neither of the groups knew if they were going to get the light or not. The experimental group got shined red light on a very small portion of their backs, only 4% of the total body surface area of these participants. So very small portion for 15 minutes after taking an oral glucose tolerance test. So they drank a whole ton of glucose, spiking their blood glucose, and then tracking their glucose every 15 minutes, testing their blood glucose every 15 minutes for the next 2 hours, seeing, what's that difference in the blood glucose regulation. And what they saw is that there was a 27.7% reduction in total blood glucose when they shined the red light on these participants' backs. So huge dramatic reduction in blood glucose just from very small 15-minute exposure of red light on a very small portion of their back, right? So I think that's a really, important study when we think about this from, like pre-diabetes and type 2 diabetes, where, our metabolism is sort of, not working properly. But even from just a health standpoint in general, we know that we don't want these huge blood glucose spikes, and we want more regulated blood glucose throughout the day just to have a healthy metabolism in general. And so the light that we are being exposed to is affecting basically how our body is utilizing food, right? Both participants had the same glucose, right? The same amount of glucose. The only thing that changed was the light. So I think, we obviously want to eat healthy food. No one should be drinking a whole ton of glucose. We want to be eating, whole foods, healthy diet and all that.
Right.
But I think what's really important is, even like separate from the food we're eating, the light we're being exposed to is affecting how our body is utilizing that food that it's eating.
Which would be better? I mean, there are a lot of red light. They're not it's super intensified like a laser, but there's a lot of red light therapy that's going on. Which would be better? 10 minutes or 10 to 15 minutes in full spectral sunlight, or 10 to 15 minutes with more, it seems like it might be more intensified than sunlight. If you don't know the answer, absolutely fine. It's something that we've tried on my son and will continue to try on my son, but maybe the best answer is both.
Yeah, so best answer probably going to be both, right? We don't, in terms of, the studies, unfortunately, we don't have studies like comparing full spectrum sunlight to, these red light therapy devices. Now,
Right.
I always go with, the best red light therapy, the best source of light in general, I always go with the sun, right? And that doesn't even need to be, what's really great is it doesn't even need to be in direct sunlight. So you can be under shade, under green shade, chlorophyll molecules in plants, which makes, plants green. Those chlorophyll molecules actually reflect a ton of infrared light. So when you go under shade, you are being bathed in infrared light, even if you're not being exposed to sunlight. So I always go with, being outdoors is always the best. I think these red light therapy panels can be useful for different like modalities, especially for, different like diseases. I mean, we have some beautiful papers, like even on like age-related macular degeneration. We have, great clinical trials on this, shining red light into people's eyes and showing them in amazing improvements. 5-year follow-up studies on these patients when they had age-related macular degeneration, 5-year follow-up after their red light exposure study, their clinical trial, still showing improvement. So that I think is, I think there's different modalities here. I mean, recovery and so many other things where I think it could definitely be beneficial. I think the big thing is, like getting those red and infrared wavelengths in the environment 24/7 when you're indoors. So I think this is, even Glen Jeffery has showed that placing a incandescent light bulb on someone's desk can dramatically improve their vision. So this is not even looking at the incandescent light bulb, just putting it on. And what he did is he tested color contrast sensitivity, which is basically the ability for your eye to differentiate between two different colors, which is a marker of visual, acuity and visual function within the eye, showing amazing improvements in just having the incandescent light bulb on the participant's desk. Now, what's interesting, he did a similar study looking at visual function, color contrast, shining a red light, basically like flashlight, into people's eyes. He told them, keep your eyes open, keep your eyes closed, whatever you want, but shining the light for 3 minutes. He showed around like a 17% improvement in color contrast. With the incandescent light bulb, it was just below a 30% improvement in color contrast. So what seems to be occurring is that the more broader the spectrum of red and infrared, the better the outcome is going to be. So with these devices, you are getting specific wavelengths. So like, with the glucose study that I mentioned, that was just one small, 670 nanometer, one wavelength of red light. And that's what you're going to be getting from these devices. I mean, some devices may have a bunch of different wavelengths. So I think they can be utilized. But I think that there is definitely this idea, sunlight is always going to be our best source. So it's like, yeah, get outside as much as possible. I will just touch on one last quick study. And going back to that previous slide with the metabolism. So this is a paper that it's not published yet, but it is currently being written up. So not published yet, not even in preprint yet. But what they did is that they took people who were working in an environment. You can see that right figure over there. They were working in this environment with an LED panel above them and a desk lamp. And the desk lamp was a typical standard LED. What they did, again, this is a randomized control trial. They in the experimental group, they took that LED, They took it apart. They put a single 850 nanometer, which is near infrared light, into the LED, placed it back on their desk, and had the people just do their normal routine, right? So they were just working normally, again, not like intentionally staring at the device or anything like that. That was just, ambient light, a single 850 near infrared wavelength of light. And they tested their glucose two ways. They did an oral glucose tolerance test, so same thing as that previous study, drink a whole ton of glucose, monitor your glucose over time. They did a pre and then post test there. And then they also used continuous glucose monitors. So they were monitoring their glucose 24/7 throughout the day. And what they saw was that the people who had that 850 nanometer near infrared light into their LED had 11% reduction in area under the curve. So around 11% reduction in blood glucose, basically, of that area under the curve comparing to the controls. And also what was interesting is that the people who did not have that near infrared, the pre versus post, there was actually either an increase or a basically steady level of blood, no change in blood glucose. So clearly this very minimal amounts of these longer wavelengths of light can have a profound impact on our metabolism. And that's ultimately coming from that mitochondrial mechanism that we talked about earlier. So I think, this is really just gets this idea that the indoor environment really is not, I would say, is not suitable for humans, right? We are not getting the wavelengths of light that we are expecting to be having 24/7. And so bringing these longer wavelengths back into the built environment is super, super important, I think. And I think, we're going to be seeing this. I mean, even, we look at just large observational studies, people who get more sunlight exposure have reductions in cardiovascular disease, have reductions in non-skin cancers, have reductions in all-cause mortality. I guarantee, one of the reasons probably for that, and this is, they adjust for exercise, they adjust for drinking, they adjust for smoking, they adjust for many different confounding variables. I think one of the reasons for that is probably that near infrared and infrared component of sunlight. There's so many other components of sunlight that could be discussed, but sunlight coming together in its complete full spectrum form is really what we need. And we're seeing that with the literature showing that the sun is so vitally important for the human body.
Excellent. Well, I am loath to say that we don't have enough time for the 60 questions that are buzzing around, at least 60 questions that are buzzing around in my mind right now. But I was wondering if Professor Jeffries, you've been in touch with Professor Jeffries?
Yeah.
Oh, good, because he should know about you.
Yeah.
But has he considered looking at individuals that have mitochondrial dysfunction or actually have been diagnosed with mitochondrial disease to see how they react to full spectral light and especially this near infrared wavelength?
Yes. So he actually did so I think he attempted to do a clinical trial, but unfortunately he didn't get enough participants for it. But in some of his presentations, he actually were looking at with young kids. I don't know the exact age, but I think it was probably around like 7 to maybe 11 years old. So younger kids looking who have mitochondrial diseases. So all sorts of different mitochondrial diseases, shining red and infrared light. And he was describing this to me, dramatic improvements. I mean, I know he was mentioning to me one girl, one child, she had very severe, barely could even like walk.
Wow.
Shining the red and infrared light and like insane improvements, able to walk, able to function a lot more normally, right? So yeah, he's a big proponent on even, with children who have mitochondrial disease. He's seen this firsthand with his research. So yeah, I think it expands to that for sure. And, that's, the group of individuals that probably need it the most,
Absolutely.
So I think that's a very important one.
Absolutely.
To talk about,
Well, I'm thankful for that. My son is operating at about 10% of cytochrome C oxidase, of normal. And so, we need to get him out in the sun more. I am so inspired just by what you've said. It's so helpful. Jonathan, how do people follow you on different platforms? How do they get to your podcast? And obviously, we're going to feature you on CHD TV. Nobody can miss that coming up on August 31st. But how else can we follow you?
Yeah, so I'm primarily on Instagram, just my first and last name, Jonathan Jarecki. That's where I post the most content on there. And then also on my YouTube which is also my podcast, The Signal with Jonathan Jarecki. I also have a newsletter that sort of accompanies that. We just, go deeper dive into all this stuff because there's so much nuance to all this research. And I that's what I love. I love getting into the nuance of all those like nerds out there. That's what I love to talk about that on my Substack newsletter as well.
Well, you're a biology professor's dream. I'll tell you that much. I needed you. If I was still teaching, I would need you to come and explain mitochondria and the electron transport chain to my class because you did beautifully. Thank you so much.
I appreciate it. Thank you, Brian. This was a lot of fun.
All right. And thank you, everybody, for joining us for this important episode. Jonathan Jarecki, so excited to have him as a part of our CHD team. Don't miss Doctors and Scientists on Friday mornings, every Friday morning at 7 a.m. Pacific, 10 a.m. Eastern Time. And don't miss Jonathan's new show.
The power we have is the truth.
This is the nation's leading conference.
It's so empowering to be joining together and working for our children.
Coming to CHD was the best decision that I've made probably all year.
It is a new day when senators and representatives want to associate themselves with Children's Health Defense. Why? We're telling the truth, and they know that. And because people are listening to us, and they know that.
To me, health on a political level is the most important subject. We need to raise a healthy generation.
We, the people, are waking up. We are taking back the system.
The federal government's job is not to ensure the stable legal risk for vaccine manufacturers.
Remember, we're a government of the people, by the people, and for the people. I can't say it any better.
We can live to see a better day where people will be healthier and where government and corporations will be forced to be more responsible.
You can't be a decent human being and know what we have now come to learn and turn your back on it and close your eyes.
My name's Mary Wildman.
Okay, and we're going to show a picture of him now. What's his name?
Nicholas Wildman.
All right, so there's Nicholas. Nicholas or Nicholas?
Yes, we call him Nick.
He's 21, and he has autism from the MMR vaccine. And there was a whole show on this family. So this is Nicholas, Billy's age, 21. And if they listened to this lady and myself and my husband and our families years ago, your kids would not be injured.
That's right.
And that's the way it is. So let's get on in here, your story. So,
okay.
Tell us what happened.
Okay, so my son at 11 months old, let me back up. A little bit before that, he was a happy baby. All milestones were right on target. He
there's a picture here, isn't it? Let me just show them. You keep talking and I'll show the peeps.
It was he started to talk. He had baby words. He walked when he should, talked when he should. Everything was perfect. He became ill with an ear infection at 11 months old. And so we ended up taking him to the pediatrician. And the pediatrician said, well, if he's not better in a week, bring him back and we'll put him on an antibiotic. Well, week went by, still wasn't any good. And I took him back to the pediatrician, where the doctor put him on an antibiotic. And of course, I gave him the antibiotic. And the doctor said at the time that if he's not better by next week, which was 2 days after his first birthday, we had a well baby appointment at that point to get vaccines and to get, make sure everything was fine at 1 year old. So we went back and I took him back at his 1 year checkup. It was 2 days after his first birthday. and he was still pulling on his ears. And I still had him on the antibiotic because we weren't done with the antibiotic.
How many antibiotics do you think you had?
I don't know. I had, yes.
That was the thing then.
Oh, we were protecting him, you know, getting him well. So I ended up, while I was at the doctor's appointment, it said on the doctor's notes that day, still pulling on his ears are inflamed, and all this is on the notes. And meanwhile, it was his 1 year checkup, so they said he's due for his MMR vaccine.
And it was just the MMR vaccine?
Yes.
In those days, that's what they did.
And so we ended up with the MMR vaccine, and they gave it to him, and he started to scream right there in the doctor's office. And I thought, boy, he didn't like that vaccine very well. Well, my mother and I were together. We dressed the baby, and she took him out to the car. I stayed and talked to the nurse. She told me he'll probably get a fever with this. Just give him baths and Tylenol to bring the fever down. And I paid the bill, and I went out to the car, and he was still screaming. And we started home. We live about 20 minutes from that pediatrician's office. About 10 minutes down the road, we had to pull the car over because he was screaming so violently. After we pulled the car over, I gave him Tylenol, and I held him the rest of the way home. And he screamed for 3 days. Fever went as high as 104. And after the 3 days, it was like I took my baby to the doctor and brought somebody else's kid home. It wasn't like the same baby. He stopped talking. He stopped looking at me. He didn't play like he used to play, didn't play with his brother. He had developed some strange tendencies, which now I know were things like pica and tantrums, and and so he ended up with me taking him back to the pediatrician again, and I said to the pediatrician, I think the fever caused deafness, because my whole idea was that nothing could be wrong with the vaccine. It must be because he had that high fever, he's deaf. So I took him back to the pediatrician. The doctor clapped his hands. Nick turned and looked at him, and he said, oh, his hearing's fine. You're going to have to work with him to make him talk. Well, I thought, okay. Well, he says to me, you have an older son. You probably give everything to the younger son as what you give the older one. And I thought, yeah, that's true, because I'm a fair mom. And so I took the baby home, and I tortured him because, I remember meltdown in front of the refrigerator where he wanted a popsicle. I gave his brother a popsicle, and he wanted one, but he couldn't ask me for it. And I'm saying to him, you have to ask me. You have to use your words. Say it. Say, I want a popsicle, Mommy. And he's on the floor screaming. And so I tortured him. And then every month I would take him back to the pediatrician and say, something's wrong with his hearing, and the doctor just kept dismissing me. Finally, on one of the visits, I got this young doctor. I think he was only doing his residency or internship or whatever. And he started asking me questions about, what does Nick like to do? What kind of toys does he play with? Well, at that point, he wasn't playing with toys like typical kids were, like my other son. And he started pulling strings out of things like washcloths and towels and bedspreads, and playing with them. He would twirl them, and then he would eat them. He had developed pica. And so I was telling him about that, and he started asking me about him playing with his brother. I said no. And Nick standing in the corner, flapping his hands with this big smile on his face, because when he flapped, he seemed happy. And he says, does he do that very often? And I said, oh yeah, he's a happy baby. Well, I didn't know the signs of autism. And I was a teacher at the time and didn't see kids coming through my classes with autism. And I had no clue what autism really was. The only kid I ever saw come through the school was a child that had Asperger's, and that was nothing like my son. So it ended up that he said, I'm going to refer you to the Child Development Center at Children's Hospital. And I said, okay, well, they test his hearing there, because I'm a believer that this is a hearing problem we have. And he said, oh yeah, they'll test his hearing. So we couldn't get in there for 6 months. And after we were called and told, your appointment is this week. When you come, it's going to take 5 to 6 hours to go through the tests. And don't bring your other son. Bring enough diapers, bottles, whatever you need. We did. It took them 3 hours. They came back and said, your son has autism. My husband's like, so how did he get it and how do we get rid of it? Because at that point he was tantruming all the time and just in his world, and we couldn't get through to him. And so the doctor, the psychologist said to my husband, there is no cause. We don't know what causes it, and we have no cure. And we were just crying when we left there.
Oh, it's devastating.
It was devastating. It was awful. So we ended up getting him therapy. That was all we could do.
Now, in those days, there was ABA was just sort of being talked about, wasn't it?
Right. It wasn't
but
even.
You had to be really rich
to
be able to afford it. So,
Insurance
like
didn't
mega
cover
rich, mega rich.
Insurance didn't cover anything back then.
Or like we were fortunate. I had a rich granny.
Oh, lucky you.
I fleeced, which made the family hate me. But what can you do? You got to do what you got to do.
That's right. Yeah. You're looking out for your
but
baby.
there was that, and then the diet was just coming in for
Yeah.
us in England. I think you may have been way more of ahead of us, but we were just starting to hear about the diet then.
Yeah, we tried the diet for 6 months, casein-free, gluten-free, and didn't see anything. And
so is he not on the diet now?
He is not.
And
no.
oh wow! And does he not have meltdowns or tantrums or anything?
No, he is a lot more controllable now. And I think that after he went through puberty, we saw improvements. Now, he is on a vitamin regimen that we rub into his back because he triggers vomiting when he takes any oral medication. So we get it compounded at the apothecary and we rub it on his back. And that's all we have him on is that vitamin regimen.
And now he lives at home with you. What does he do?
Well, he just graduated from high school.
Nice.
Yeah, he's 21, and the kids can go till they're 21. So
and he enjoyed it there today.
He loved it.
Okay.
And now we have nothing, because it's like after the kids graduate, then they're no longer.
What does he want to do? What does he say he wants to do?
Well, he's still nonverbal at this point.
Right.
He's doesn't really have a good communication system. He uses on an iPad, and he also has sign language, some sign, but my concern is that he needs 24/7 care because he's one of these kids that's a safety risk. He's a runner. He will escape.
So he's just at home with you?
Right now.
Yeah, that's not.
I'm hoping to start a program for kids with autism.
Good for you.
Yeah.
He's 21, so same age as Billy.
Yeah. And we were in the omnibus cases. We did file. I asked the pediatrician to fill out the VAERS report, and they would not, so I did. And then we were filed through the Compensation Act, and we're in that case for 15 years. We had a lawyer file it for us, but it was a family friend, and he really didn't know too much about, defending people on the spectrum, or how to even go about filing cases like this. And after the first case was tried with about the MMR, the Cedillo case, he backed out of our case. So he said, "There's no way to win this," and so I was the one that ended up fighting it because I couldn't find another lawyer that would take the case. And I believe that if the lawyer wouldn't have put down that it was autism, that it was encephalitis or some other cause.
The word autism, isn't it?
Yeah, it's the word autism. Yeah. And I think we would have won. But because I can't prove what causes autism, then we lost that. And that was lost at the beginning.
I'm sorry.
Mm-hmm.
This and all CHD TV programming is made possible by generous support from viewers like you. Please consider making a contribution today to keep our programming going strong. Thank you.